Good morning, students. So, last class we were discussing about latent heat of fusion and latent heat of vaporization. So, you know what is latent heat of vaporization? It is the amount of heat energy required to rise 1 kilogram of a amount of heat energy required in order to change 1 kilogram of a liquid into gas at its boiling point at atmospheric pressure, isn't it? So, it is the amount of heat energy required to change 1 kilogram of a liquid into gas state at atmospheric pressure at its boiling point. That is called latent heat of vaporization. So, so I think you understood what you mean by latent heat and latent heat of fusion and latent heat of vaporization. So, today we know that when solid melts, it converts into liquid, and liquid melts liquid on heating, it converts into gases, isn't it? Now, there are certain substances, they are directly converts from solid to gases, without changing into liquid. So, solid to gas, directly they convert solid to gas without changing into liquid. That is called, they are called that type of reaction is called sublimation. That is called sublimation. For that, take a china dish. And take some ammonium chloride. Powder of that is crystals of ammonium chloride in a china dish, and place it in a tripod stand and then heat. And on heating, you also invert a funnel above this china dish. So, when you are heating, and also here you place a cotton plug. You have to close the this end with a cotton plug. So, when you are heating ammonium chloride, it evaporates or it sublimes. So, when we are heating, this ammonium chloride directly changes into gas state, and they stick on this surface of these sides of the funnel. On this, when it is cooled, that will be more ammonium chloride particles will be sticking on the surface of this funnel. So, this type of reaction is called sublimation. That is, when a solid directly converts into gas state without changing into liquids, that is called sublimation. And ammonium chloride is a sublimable substance. Then naphthalene, then another example, camphor. All these are examples for sublimable substances. So, this is called sublimation. Now, next we are going to discuss the effect of, so all these are the effect of temperature, on changing the state of a matter. So, now we are going to discuss about the effect of pressure. On changing the states of matter. So, for that, in order to understand, take a cylinder having a piston. So take 3 cylinders. Take 3 cylinders. So in this cylinder, the first cylinder, you take what? You take gas. So this is gas particles. First is filled with the gas, and this is the piston. And the second one, you take water or any liquid. So we know liquid particles. Liquid particles. And here you take a solid particle. So these are solid particles. So you can see that here the gas particles will experience low pressure because we know the gas particles they are loosely packed. The particles, they can move freely, they are loosely packed, and hence they experience very less pressure. But what about liquid and solid? They experience high pressure, isn't it? They experience high pressure. So the particles in the solid and liquid state, they don't have much impact on this piston. That is, pressure has no impact on these solid and liquid particles. But in gases, we can compress easily. And if you are compressing, if you are exerting high pressure on the gas particles, the gas particles may change into liquid, because when the gas molecules come close together, so they may change into their next state, that is the stage, that is liquid state. Because there is the force of attraction between the particles are more as compared to gases. And again, if you are compressing, sometimes it may change into solid state. But in the case of liquid and solid, there is no impact of pressure on these particles. And that is why, you know, LPG gases, liquefied petroleum gases, we can in a small cylinder or in a small container, by applying high pressure, we can liquefy them into that is, gases can be liquefied by applying high pressure. So by applying high pressure and lowering the temperature, we can change the states of matter. By applying low temperature and high pressure, we can change or we can liquefy a gas. We can liquefy a gas by applying high pressure and low temperature. Okay. So this is the effect of pressure. Effect of pressure on gases is it is practicable, but in the case of there is no impact of pressure on this liquid and solid. Okay. Now the next topic is evaporation. Evaporation. You know what is evaporation? There are many examples. For example, wet clothes dry up. They dry if you are spreading, that is under sunshade, or this one, if you are spreading your wet clothes in dry areas or in open area, it will dry. And then many other examples you can see during summer season, the water bodies, they get dried, you know. Why? Because of evaporation. So what is evaporation? whether we are heating the we know the liquid particles, they convert directly into gases. At that time, whether we are heating into the, up to their boiling, no, we are not heating. So what is evaporation? So evaporation is a process of converting a liquid into gases at any temperature below its boiling point. At any temperature below its boiling point. So it is a process of conversion of a liquid into gases at any temperature below its boiling point. So a number of examples are there for evaporation. As I told you that this one, wet clothes dry, and then that is evaporation from the water bodies. All these are examples for evaporation. Okay. Now, next topic is, what are the different factors which affect the rate of evaporation? Factors affecting rate of evaporation. Factors affecting rate of evaporation. The first one, temperature, high temperature or increase in temperature. So as temperature increases, the rate of evaporation increases. As I told you one example, that is, when if there is a sunny day during or summer day, the water bodies get dried. Why? Because of the heat of the sun. And then the wet clothes dried during summer, it will be dried more earlier than during winter days. Why? Because of the heat of the sun, isn't it? And then another example, for example, if you are having fever, and then your mother may give you a cloth, that is here, wet cloth will be placed here in the forehead, no? And why? Because it will absorb, that wet cloth will absorb heat from your body. So that is also happening, that evaporation will happening, because it will absorb heat from your body, and you may, that is the body temperature may be lowered. So that is, all these are examples for evaporation. So that evaporation can be speed up by increasing the temperature. So increase in temperature, it will enhance the rate of evaporation. And then the second one, surface area, increase in surface area. As the surface area increases, the rate of evaporation also increases. There are many examples for this. For example, if you are taking a hot milk or hot cup of tea, if we are using cup and saucer, so when we pour hot tea or hot milk in the saucer, we can drink it easily, we can sip it, no? Why? Because there is evaporation takes place easily if they are spreading. If there is more surface area, then they will evaporate very easily. And we know wet clothes will dry easily when we spread it, isn't it? When we spread it, or if we fold it, it will take more time to dry, isn't it? So and then there are many examples. For example, if you are cleaning the floor, at that time we will wipe the waters using wipers. So at that time it will easily dry, because we are providing more surface area. We are providing more surface area to dry. That is why it will evaporate easily. So as the surface area increases, the rate of evaporation also increases. And the third one, decrease in humidity. decrease in humidity. So, what is humidity? Humidity is the amount of water vapor present in air. It is the amount of water vapor present in air. So, if the amount of water vapor is more, we know our surrounding air can they can hold a definite amount of water vapor. Only a definite amount of water vapor they can hold. If the water vapor is more, then again the rate of evaporation will not happen. Why? Because if the amount of water vapor is more in the atmosphere or in the surrounding, the rate of evaporation decreases. So, when the humidity is more, the rate of evaporation decreases, and that is why during winter season it will take more time to dry the clothes than in summer season. Why? Because in summer season the amount of water vapor is very less, that's why they will evaporate more, not only because of the heat of the sun, and if there is humidity is there, during July and August month, even though the temperature is very low, the humidity will be more, so at that time the rate of evaporation will be very less. So, as the humidity decreases, the rate of evaporation increases. So, decrease in humidity enhances the rate of evaporation, and increase in wind speed. Increase in wind speed. If we dry the clothes under a fan, it will dry more easily, and if we keep your dress near to or in a corner or in a cupboard, if you are keeping that in a cupboard, that is wet clothes, then how many days will it take to dry up? It will take more time, isn't it? But when we keep these under the fan, so at that time the rate of evaporation increases, because more particles, the particles that is present on the surface of the cloth will get more kinetic energy, and it will take away, those particles will take away along with the wind. So, that is why the rate of evaporation increases, and so the increase in wind speed will also enhances the rate of evaporation, okay. All these are the different factors affecting the rate of evaporation. That is high temperature or increase in temperature. Increase in temperature favors the rate of evaporation, and increase in surface area favors the rate of evaporation, and decrease in humidity and then increase in wind speed. All these are the different factors which affect the rate of evaporation. Then next, the next one is that evaporation causes cooling. Evaporation, it causes cooling. How evaporation causes cooling? We know when evaporation is taking place, the liquid particles, they absorb heat energy from the surrounding. The liquid particles, they absorb heat energy from the surrounding. So, when these heat energy absorbed from the surrounding, that is these heat energy, they are absorbed from the surrounding. So, in order to evaporate these liquid particles, they absorb heat energy from the surrounding, and that is why the surrounding feel cool. The surrounding feel cool. In order to escape from liquid to gas state, they require some amount of kinetic energy, and that kinetic energy, that amount of energy, they are absorbed from the surrounding. So, when they absorb heat energy from the surrounding feel cool. There are a number of examples are there. For example, if you pour some acetone, acetone is what nail polish remover, that is acetone, or any spirit. If you are pouring some amount of acetone or spirit in your palm feel cool. Why? Because in order to evaporate that acetone, they absorb heat from your palm, and that's why your palm feel cool. your palm feel cool. And then number is that, if you are keeping water in earthen pots, that pots having many small pores. So these small pores, through the small pores water is entering, and then when they expose it to air, they evaporate. So in order to evaporate, they absorb heat from the remaining water. In the earthen pores there are many small pores are there, very small pores are there. Through these small pores water enters into these small pores. So when they expose it to air, when they reaches the outer surface of this pot, they will evaporate. So in order to evaporate, they absorb heat from the remaining water, and that's why the water inside the pot feel cool. Okay. And then another example is that, a number of examples are there. Another example is that sprinkling of water on the roof of the houses, or in the roads. So they will when we sprinkle water, so they will absorb heat. That water will absorb heat from the roof or from the road, and they will evaporate. So that evaporation makes the that roof cool. So all these are different examples for evaporation causes cooling. Evaporation causes cooling. Then another thing is that that topic is also related with the evaporation. That why do we wear cotton clothes during summer? Why we are wearing cotton clothes during summer? So here also is an application of evaporation. That is, when we wear cotton clothes during summer, cotton is a good absorber of water or sweat. We sweat, we perspire more during summer, isn't it? So at that time when we sweat, so that sweat particles enters into the cotton, and cotton, many small pores are there. In cotton clothes there are many small pores are there, because they absorb, that is why they absorb water. So when they expose it to air, they evaporate. So for doing that evaporation, they absorb heat from our body, and that's why our body feel cool. You understand? That is, when we during summer day we sweat more, we will sweat more. So that sweating, that sweat will be absorbed by the cotton cloths, and when they expose it to air, they evaporate. So for that evaporation, they absorb heat energy from our body, and that's why our body feel cool. Okay. And that the water, if ice cold water is kept in a tumbler, you can see after some time on the surface of the tumbler you can see water droplets. So what is the reason for this? So the reason is that when air, that is, or water vapors that is present in the atmosphere, they come in contact with if this is a glass tumbler, then when water vapors are in contact with this surface, so this surface, we know this is a cool surface, this ice cold water if we are taking in a tumbler, glass tumbler. So when these water vapors are in contact with this surface, they will condense, they undergo condensation, or they will condense, and then they will change into liquid state. That is why, so this water vapor is changed into liquid state. That is why on the surface of the glass tumblers having ice cold water, many droplets can be seen. So that is because of condensation. Okay. So these are the different interconversion of different states of matter. So generally we can represent that is solid. A solid, if a solid is converted into liquid, so here these are the three states of matter: solid, liquid, and gas. Solid, liquid, and gas. If a solid is converted into liquid, what we call solid is converted into liquid, that is called that is called melting. That is called melting, isn't it? Then when liquid is converted into solid, that is called freezing. That is called freezing, or otherwise it is called solidification. It is called solidification. Then liquid converts into gas. Liquid converts into gas, we call as vaporization. Vaporization. And gas converts into liquid. That is called condensation. When a gas converts into liquid, that is called condensation. Then solid converts into, when a solid converts into gas, that is called sublimation. And when a gas converts into solid, it is also called sublimation. So two ways we can define what is sublimation. Sublimation is a process of converting solid into gas without changing into liquid on heating, or vice versa on cooling. Vice versa means gas convert into solid on cooling. That is called sublimation. So this is the different state. We can interchange the different states of matter. That is, solid can be converted into liquid. So that is called melting, and then liquid converts into solid. That is called freezing. This is also called melting. Is also called fusion. Then when liquid converts into gas, that is called vaporization, and when gas converts into liquid, that is called condensation. When solid converts into gas, directly into gas, that is called sublimation, and the reverse is also sublimation. So these are the different states of matter and their interconversion of different states of matter. Hope you understood. So with this we have finished our first chapter. Okay, thank you. Have a nice day.